Hello and welcome back. In this lecture, we will be learning about Azure's products with respect to databases. When it comes to the databases, database systems are used to collect, organize, and manage large volumes of data. They are a valuable part of any organization infrastructure. Azure offers many database options. You see this a screenshot will show about a lot of other options that you have. Let's go to the presentation mode and see what kind of databases we have. So if you see the screenshot which I have taken from Microsoft Azure databases documentation, you can see here you have a lot of different databases like CosmoDB, which is a globally distributed database, and you have the SQL database and Azure database for Postgres, and SQL database again, and you have many other different of the databases. So most of the time we call these are the managed databases. When I say managed databases, mostly it would be a PaaS. So that means a platform as a service, where these databases are hosted within the Azure cloud for high availability purpose. There are also other databases which are available as a VM format. So they offer you as the pre-installed configuration for you, and it is your responsibility to handle the entire VM configuration, where we call it as a non-managed databases. We are going to talk that in a minute or so. For the previous slide, we are going to talk about the same descriptions. If you can see here, each database has a different description with a one line. If you see here, the CosmoDB, it's a multi-module database for any scale. And Azure database is managed and intelligent SQL in the cloud. If you go to the Azure portal and look for getting started, within the marketplace you can search for the databases, and you see here some of the databases are available like Oracle database or different type of databases which are directly coming from the marketplace, where the publisher is already configured and pre-built-in configuration is already done, and it is readily available. If you're just going to the VMs and search for SQL VMs, there are also VMs available directly, either published as a Microsoft or third party, and you can use that as the infrastructure as a service also. So let's jump into each of the products that we have seen in the first slide here, and we also have a here one line description, but we didn't discuss much. Now I'm going to talk about the first one. I will start with the SQL databases, and then I'll jump into other kind of databases, and I'm going to talk on almost all the databases that are most important or widely used within the Microsoft Azure cloud. So the first one is Microsoft SQL database. Azure SQL database is a very mature and advanced database. Azure SQL database is perfect when you need to store relational data in a transactional system with heavy duty querying capabilities. Azure SQL database is a fully managed cloud equivalent of your on-premises SQL service, a product that has been around for decades. It is a schema-based system where the structure of the data is encoded in the database plan. We store data in a tables with rows and columns. It supports familiar SQL Server features like stored procedure, user-defined functions, and all of that TSQL specific things. So relational database, it's offering as a relational database as a service directly from the Azure cloud. When you try to enable SQL database as a service, you always get the latest SQL, which is a stable version, will be enabled for you. And you can migrate databases directly from your on-premises to Azure database as a service with another tool called Data Migration Assistant. And SQL performance purely based on DTUs. So DTU is nothing but your CPU IO's memories. They are called in a short database transaction unit, because this is where your performance is measured. So you have DTUs, so you can increase the DTUs to get more improved performance. Let's try to understand more about the DTUs. DTU is an abbreviation for database transaction unit, and it describes a performance unit metric for your Azure SQL database. We can just like think about it as a DTU to the horsepower in a core because it directly affects the performance of your database. So DTU represents CPU and memory and IO operations, that's the input data output operations, and as well as the log input output operations. So the main idea of the DTU concept is to offer a pre-configured resource configuration to the client so that it simplifies the scaling of the performance of your SQL Server or a single metric, such as if we need more performance, we can slide the bar and increase the number of DTUs within the SQL database. DTU-based purchasing model contains three different tiers, and these service tiers offer a different DTUs and features and options based on your IOPS and other configurations. So they are, the first one would be the basic tier, other one would be the standard tier, and the premium tier. So within these basic, actually it's a starting model where you can go for the development or a little bit of production with a very lesser workload types. So if you see here, the CPU power you'll get is a very low, and you can go from anywhere 1.5 ops per DTU, and IO latency approximately 5 milliseconds and 10 milliseconds if you write it. So these are for the read and write. And in memory or LTP DTUs are 5 here, and maximum storage is only 2 GB of the database. And whereas the standard, it actually you can go up to 250 GB with up to 300 and maximum DTUs with a standard S12. So when it's a standard, you do have S1, S2, S3 kind of things. So as you scroll the bar to change the DTU power, it actually changes the plan. And if you see here, these are mostly configured for the standard of your pre-production or production kind of thing, but the premiums are mostly it would be production. And apart from this, you also have a business critical and other vCore models, but mostly this should be, you should be able to understand this. And one of the major other difference would be the backup retention period. If you see here, 7 days for the basic, whereas for the standard 35 days, and the premium also 35 days. And also you have the elastic pool specific EDTs also, which we are going to look at in a minute or so, but this is how the performance is measured, just for the basic information here. And you have a different pricing types also, and that also depends on DTUs. So as you go for the higher performance, you also get the DTUs higher, as well as the elastic pool configurations also can be done. Let's try to understand more about elastic pool or EDTUs. So elastic pools enables the developer or the buyer to purchase resources for a pool of shared by multiple databases to accommodate unpredictable periods of uses by individual databases. You can configure resources for the pool based on either on a DTU based purchasing model or based on the vCore purchasing model. As I explained earlier, vCore mostly we used for managed instance, which is I'm going to talk in a minute or so, but these are the two different purchase options you have. One would be the purely based on the DTU based purchasing model, other one would be the core based purchasing model. So the resources required for a pool is determined by the aggregated utilization of its database. So the amount of the resources available to the pool is controlled by the developer budget. So the developers simply adds the databases to the pool and sets the minimum and maximum resources for the database, either minimum and the maximum when I say DTUs, or the minimum or maximum vCore based on depending on your chosen of the resource model, and then sets the resources of the pools based on their budget. A developer can use seamlessly grow their services from lean startup to a mature business at ever increasing scale. Within the pool, individual databases are given the flexibility to auto scale within set parameters. Under heavy load, a database can consume more resources to meet the demand, and databases under light load consume less, definitely. And databases under no load consume no resources, definitely. So the logic is here, the provisioning resources for the entire pool rather than for single database simplifies your management tasks. Plus, you have a predictable budget for the pool. Additional resources can be added to an existing pool with no database downtime, except that the databases may need to be moved to provide the additional compute resources for the new EDTU's reservation. Similarly, if extra resources are no longer needed, they can be removed from your existing pool at any point of time. And you can add or subtract databases to the pool. If the database is predictably underutilizing resources, move it out. So that makes easy. Let's take one example here. In this graph, the database that spends most of the time is idle, but periodically it is actually spiking with some kind of activity. So this is a utilization pattern for suited for a pool. In this graph, we also notice that the spiking is at close to 90 DTUs calculation, around 1210, and also there are other spike up to 50 DTUs between 1215 and 1205 as well as 1255. So let's also look at another graph which explains very similar but with a combination of four different databases. So assume that there are four databases like DB1, DB2, DB3, DB4. So these are the four different databases. If you see, it is spiking sometime close to the 90 DTUs. And another database, if you take it another database with a combination of all DBs, which are 20 different databases, you see here it's actually spiking close to the 90 between 1210 to 1255, and the remaining time is ideal almost, or they're not even touching up to 40, or some of them are close to 20. So this is the right set of databases that can be used for elastic pool or EDTU's purpose. So we can consider these things, and we can save a lot of cost when we consider for the database, and we can add, we can remove within the pool so that we can have a full control in our hand. If you're trying to learn how to calculate your DTU's configuration, this is a website which is dtucalculator.azurewebsite.net, which gives a handy tool where you can easily calculate. After downloading this tool, you can simply upload and say that calculate. That actually gives the good calculation for the SQL databases, and what kind of uh, DTUs you need to end up, because in your on-premises you might be having maybe 10 cores or different max of the RAM and the CPU, and as well as the database input output configurations on your on-premises. And if you try to move to the past model, you need to have some kind of tool that would actually tells for the easy sizing or the planning side. So this is one of the easiest tool that you can use, like dtucalculator.azurewebsite.net. This chart explains about how best we can go for a closest DTU configuration based on our on-premises configuration. If you look at here, maybe if you have the single core processor, and you may be having up to IOPS, if you just run any of the IOPS configuration tool, you would be coming to know that what kind of IOPS you are getting. So based on that, you can calculate, or just closest that you can match it. Like DTUs, you might need up to 100 DTUs, and if it is a 4000 IOPS, then you might be end up with 500 DTUs. And in the basic tile size, if you look at, we talked about the basic and standard and the premium, if you remember, and within that it actually falls under premium P4 or P6 or P11, P15. So these are the chart which explains what kind of sizing should be matches when we look at from on-premises to past model. This would be a useful chart based on my experience, I can talk. And also definitely, as I explained earlier, you can use that as your website to get a calculated a closest DTUs for your configuration. And also Microsoft provides a number of different deployment options for its SQL database offerings. One of the offering would be SQL database managed instance. So when we talk about SQL managed database instance, it actually talks about your database services that are running on your on-premises can be migrated to the cloud. For example, you see here this database can be migrated from your on-premises to with a limited touch-ups, you can directly migrate and you can manage as a PaaS platform. So within the PaaS, if you see here, single elastic pool as well as the managed instance, these are the three different types what we have. And let's have a demo along with the some of the overview how it looks like. From your on-premises, you might have different applications powered by SQL Server. You want to migrate to modernized with Microsoft Azure Cloud, and there's a lot of applications that have a complex environment and things like your complex things. When I say the complex things like SQL CLR, maybe SQL Server agent, or even the cross database queries that needs to be work when you migrate to PaaS model. And in the past, these dependencies definitely prevented you to migrate to a managed PaaS service model. Well, the good news is that with all these complexity, also you can now fully migrate it with the help of SQL database managed instance. That means you have full of intelligent database services with zero code change. If you see here, this is one of the application which is hosted on a local server called, if you see here, this is the hosted on a local server for the current SQL version is 2008 R2 with 10.506549.0, and this gets migrated to the latest version, at least to the 14.0 once the migration is completed. This runs with the different applications in the backend. So if you see here, I'm just trying to create with the Stack Overflow migration wizard. I'll just go to directly from the managed instance and within the portal and fill the required things like the server name, and the source name and the target to whatever the server you want to provision in the cloud, and then you can map the target databases. So on the source, whatever the databases are there, for example in this Stack Overflow database is available, so that becomes as a source as a target, and that gets automated migrated with the configuration, and you can take the backups of your SQL database within that step and simply enter the activity name. So that actually runs as a backend with a job, and this would take a minute or so. If you see here, it's actually in the backend, it has completed this job. That means the databases are now fully migrated. As a next step, all I have to do is I have to change the code on my application. So this is my application. So within this application, instead of my on-premises, I'll just comment that and I'll just give this as the cloud-based PaaS model database server name, SQL database server name, and the application works fine. If I just refresh and if I just go down, I should be able to see here the database as the cloud. And you can also talk about the performance side. So if you look at the performance side, you have different queries are running. So we never know that what query is taking longer time. With the help of your SQL database now within the Microsoft Azure will provide you a longer running queries information, and you can drill down what query actually making a lot of load, and you can fine tune that. So these are the one of the benefits. Like if you just click on that recommendation, you can see which query is taking, and you would see exact query information, and you can even change the query if you want, and you can fix the query in order to take only a lesser load. So you see here the query is available, or you can just copy and modify that query, or even you can run the automation jobs by taking automation. So here you can see here you can create the index, or you can drop index. All that kind of intelligent options can be configured right from your database within Microsoft Azure. So this is very powerful, and the most advanced security concept would be the threat analytic ATP, also now compatible with SQL databases. This is not just for the SQL managed instances. This can be any of the databases that are hosted on your Azure. So if you just click on vulnerability assessment, you have the option that will scan any database using a series of best practices, so I can maintain a secure and compliant database. For example, many of you maybe needed to comply with your company's regulation requirements, or maybe agent requirements like GDPR or PCI, among of many other things. The vulnerability scan assessment can detect where I have a sensitive data being stored within my database and whether it is following all the best practices or recommendation steps that are followed to protect your data. So I can take actually a quick action here, also automatic. If I just click on that, I can take an immediate have a look on it, and within the portal, and I can take a dynamic action to remediate right from the portal by looking at what kind of data is getting leaked, or what kind of data is not secured. Okay, to conclude, SQL database managed instance, with SQL database managed instance, you can migrate any of your on-premises SQL servers. Maybe you have a complex configuration within that, like CL or SQL agent, or cross database queries, or native restore, or service broker. All that different complex configuration specific SQL servers also as it is can be migrated to managed instance, and by doing that you get the fully advantages. So when I say advantages, like it's fully automated patching and all the benefits that you get it with the PaaS model, you automatically get it directly from the Microsoft, and you don't need to worry about the uh, configuration side, how to manage all that databases, because it's fully managed under PaaS model. Other type of database offering from Microsoft would be Azure Synapse Analytics, formerly also known as the SQL Data Warehouse. It is purely designed to store large amount of the data in structured relational format for reporting and analysis purpose. Based on the SQL Server database, basically it works, and the warehouse stores, or the Synapse, basically it stores the data in a tables with rows and columns, and definitely it will have the features like indexing and constraints and keys. The difference is that SQL database, that is the Azure database, is the best for transactional input, while uh, Azure Synapse Analytics is fully optimized for reporting purpose in general. So it is better at handling complex queries. It can hold unlimited of amount of the data that actually that makes Azure Synapse is to work with the enterprise data warehousing, especially for the big data analytics, and it gives you a freedom to query data in your terms using either serverless on demand, or even it can work even the provisioned resources at any scale. Azure Synapse Analytics will be used for immediate BI and machine learning tools. And if you see the big components of the big data, so if the data is coming either from the IoT or maybe social profiles, or maybe imaging graph, whatever it is, the data, it can be processed with the help of the data orchestration and monitoring, and that actually stores in the big data store, and on top of it, it actually runs some kind of preparation tools, and then it will train the database to get the required outputs with the help of either um, Hadoop or Spark kind of tools, which will be used along with the machine learning tools. And then we actually gives the model and the serve with the help of the data warehousing, and that actually gives the output for the applications inside informations. That's the high level design of the big data, and this has been very clearly discussed in the Azure 900 series exam course. You can check out that if you're interested. And let's move to the another topic. So the other topic would be the data lake storage. Azure Data Lake includes all the capabilities that are required to make it easy for developers, data scientists, and analysts to store data of any size. It can be either petabyte size of the files, or it can even trillions of different objects, and the shape it can be a different, or the speed, all type of this processing and analytics across the platforms and different languages. It can be performed within the Azure Data Lake storage, and it removes the complexities of ingesting and storing of all your data while making it faster to get it up and running with batch or streaming or interactive analytics. All this is possible with this. And if you see here, you have a different tools that can be used within this. Azure Data Lake works with existing IT investments for identifying, managing, securing, for simplified data management and governance purpose. It also integrates seamlessly with your operational stores and data warehouse, so you can extend current data applications that you have, and we can draw on the experience of working with enterprise customers and running some of the largest scale processing and analytics in the world of Microsoft business like Office 365, Xbox Live, Azure, or Windows, or Bing, or for that matter Skype. Azure Data Lake solves many of the productivity and scalability challenges that prevent you from maximizing the value of your data assets with the service that is ready to meet your current and future business records. So this is the high level of data lake where you can use the Hadoop or Spark or clusters of HD inside or analytics services. And then for the storing, it can store the structured, unstructured, or semi-structured data type. Let's have a look on the next database type is Cosmos DB within Microsoft Azure. Microsoft has put a lot of thought and efforts into building our next generation platform for Cosmos DB, and it could be well become the dominant of the system within the Microsoft Azure cloud database ecosystem. It's a globally distributed multi-model database service that supports document storage and key value wide column graph database. That means if you have non-relation or NoSQL database or data, then this is a good candidate for storaging. So that's where it supports the Cosmos DB. So essentially, Microsoft has created a universal backend for different kinds of databases. Because of this flexible approach, it can adapt over time to include new concepts being investigated at Microsoft Research, built from a ground up with global distribution and horizontal scale as it codes. It offers actually a global distribution across any number of Azure regions by transparently scaling and replicating your data wherever your users are. It has a adaptable approach to data consistency, so you can choose a speed and timing that fits your business needs. Basically, if your application needs guaranteed fast response time anywhere in the world, it is required to allow us um, to be always be online and needs unlimited and elastic scalability of through output in storage, considering building applications with the help of Microsoft Cosmos DB. That being said, it also offers a lot of other APIs, like if you see here SQL, MongoDB, and other definitely other APIs also available within the Cosmos DB. One of the database type would be the PostgreSQL and MySQL, or popular systems within the world of open source relation databases. Recent years have seen Microsoft embrace the open source community, and now organizations can use the PostgreSQL and MySQL databases on Azure. And the key to making this work for Azure is the extensive work done to build a cloud databases hosting system that supports a variety of relational databases. PostgreSQL is an object relational database. Once it's provisioned on Azure, you can access it using all the native Postgres tools like PG admin, like all those tools. And Azure MySQL is a relational database that based on an open source community called MySQL. Once it is provisioned, you can access it using all the MySQL, like MySQL Workbench, all other tools. So here we are actually talking about the two different tools, but these are all the open source community. And other type of databases, definitely as your table storage is a non-relational key value pair storing or a storage system that's suitable for storing massive amount of unstructured data, as your storage tables can store tabular data at petabyte scale, non-relational storage like table storage, are optimal for simple retrieval and fast inserts. This predates Cosmo DB is a simpler version of the key value storage values at a Cosmo DB. So that's where Cosmo DB came, and it is still a useful way to store data. It is especially good and cost effective if you don't need the high throughput global distribution auto indexing features of Cosmo DB. So that's a brief look at a variety of databases available within Microsoft Azure. So within Microsoft Azure, there are sure to be one or more choices that you will have so that you can choose your best needs.